In this video, we're going to be looking at another relationship that lets us solve for sides and angles of non-right triangles, again using the cosine trig ratio from right triangles. Now we could go in and prove law of cosines the same way that we did for law of sines in the other video, but it is a little bit more complicated as far as a proof goes, so I'm just going to give you the relationship. So again, you notice on this triangle, opposite sides and angles are labeled using upper and lower case of the same letters. You have three different forms of law of cosines here, but you don't really need to memorize the different forms. What you want to think about are some of the patterns that you see happening in these equations. So if you'll notice, you can think Pythagorean theorem. I'm taking the three side lengths. Now the one that goes out in the front of the equation is a specific side, and we'll talk about that in just a second. But the other two sides are both squared. So 3 sides squared, a squared, b squared, c squared. We use that 100 times with Pythagorean theorem. Now the number that, or the variable that goes out in the front needs to be opposite of the cosine where the angle is found. So if I know angle B, and I'm going to set this up to find side length B, then B should be the side length that goes out in front of the equation, and then the other two sides will become A and C. And again, it doesn't really matter there with the addition and the multiplication. We just want to be consistent. The -2 is always part of the equation. They're all -2. You'll notice that the sides being multiplied by the -2 are the two that I'm using on the same side of the equal sign together. So the b squared and the c squared, -2bc, and then in cosine of the angle that is out in front of that equation. And that happens on all three of those equations. So again, I don't necessarily think about using a different form. I just think about more, what is it do I know? What is it that I'm trying to find, and what can I take and set up together? You can use law of cosines and law of sines together, meaning if you're asked to solve a triangle, if you have to start with law of cosine because you're given 3 sides, or you're given two sides and an included angle, you can start with law of cosine and then switch to law of sine, because law of sine is much easier to navigate through. You do have to be really careful with law of cosines, making sure that you're following appropriate inverse operations and order of operations to solve. But if you're given 3 sides or 2 sides and an included angle, you're going to have to use law of cosines because you don't have an angle and an opposite side in order to set up and solve using law of sines. Okay, so that's a lot. So sometimes with this, it's just a little bit easier to get into a problem and work through the problem first. So we are going to find side A in this triangle. So the first thing that I look at is I have 2 sides and I have the angle in between those 2 sides. So side, angle, side, which means I have to use law of cosine. And then angle A is 115, and it's opposite of A, which means if I'm going to have to use the cosine of 115, that side length A has to be the one that's out in front. So a squared equals b squared and c squared. It really doesn't matter which I call which here, because I'm just going to take both of those numbers, square them, and add them together. We said that -2 is part of the equation, and so I use that every time. The 42 and the 53 get multiplied by the 2 because they are, again, are on the same side of the equal sign together. And then it's the cosine of the angle opposite the side that's out in front. So that's 115. And then we just have to work on simplifying. When I work these, I kind of work these step by step because I want to make sure that I don't break any rules. So I typically start by adding together the squared values in the front. So that's going to be 4,573. -2 times 42 times 53 times cosine of 115. So I'm going to give you just a little word of warning here. This -2 you need to be really careful. You either need to, on your calculator, type it in as -2 times that value, or when you are doing your second step here, you would have to write minus and then whatever that number is, and remember that if it's a negative, you're adding a negative, which is going to change it to addition, which is why I typically type in on the calculator and make it a -2, so I don't have to worry about any of that. So I'm actually going to end up with a positive 1881.5. Those two numbers get added together, so 6,454.5. And then if you'll notice, this is not a, this is a squared. So the last step is going to be taking the square root of that number to get the final answer, which tells me that that side length is going to be about 80.33. So when you're not solving for the angle, it's pretty straightforward. Again, you got to be careful with the -2 and make sure that you're getting all of those numbers in there together. So what happens if I'm solving for an angle measure? So this would be side, side, side. I don't have any angles. I can't set up law of sine. I'm going to have to use law of cosine. If I'm solving for angle A, I'm going to want to put the side opposite that one out in front. So 23 squared is equal to the other two sides squared and added together. So 17 and 19. Again, it really doesn't matter which one's B and which one's C. Minus 2 is part of the equation. So 17 times 19. And then we would say the cosine of angle A. So as you can see, the variable that we're solving for is way back here in this equation. We got to multiply some stuff together, which means we're going to have to undo that with division. So just be very careful as you're working through this. So 23 squared is 529. I'm going to go ahead and square and add together 17 and 19, which is going to be 650. I'm going to go ahead and multiply together 2, 17, and 19, so minus 646 times the cosine of A. Students really like to subtract these two numbers right here, which you cannot do because 646 is being multiplied by the cosine of A. So be really careful that you don't try to subtract those two numbers. The next step here would be to subtract 650 from both sides of that equation. When we subtract 650 from both sides of the equation, we're going to get negative 121 is equal to negative 646 cosine of A. Divide both sides by negative 646, so we end up with 0.1873 is equal to cosine of A. Anytime that we're working with angles or finding the angles, we have to use our inverse. So we would type into the calculator inverse cosine of 0.873, and the calculator is going to tell us that our solution is 79.28 degrees. Cosine is a one-to-one function, so if you think about your cosine graph, when it crosses your axis, it's going to cross at the peak or the valley. It comes down across at 180. So it's not going to repeat in that interval of 0 to 180 degrees or 0 and pi. So we don't have to worry about an ambiguous case with law of cosines like we did for law of sines. So the last example, they give us a description, but they don't give us a picture. So we're going to have to put some of the information together. So it really does not matter what you make that triangle look like. So there's triangle ABC. They tell me that A is 17. It's lowercase, which means it's a side length. It's got to be opposite of angle A, so I'm going to put that over here on this side of the triangle. C, lowercase, again, it's got to be opposite of angle C, so that's 34. And then they tell me that the measure of angle B is 94 degrees. So we have another example where we're using side angle side, and they want me to find angle B. So there's my relationship between the angle on the opposite side. So we're going to set up B squared is equal to 34 squared plus 17 squared minus 2 times 34 times 17 times the cosine of 94. And so now we just have to simplify. So 34 squared and 17 squared is 1445 minus 2 times 34 times 17 times the cosine of 94 is going to give me a positive 80.64. When I add those together, b squared is equal to 14. It's actually equal to, sorry, I had to get the calculator out, 1525.64. And then again, to get b by itself, I would have to take and find the square root. And the square root is 39.06 approximately.